These cells are responsible for healing and building of new bone.
You know, I'm here at Case Western Reserve University in the Biomedical Engineering building. I want to talk to someone about mechanobiochemistry who can really help me figure out what these bones are all about.
I'm Melissa Knott-Tate. I'm a professor in biomedical engineering at Case Western Reserve University. This large bone here is the bone from a young elephant. You can tell it's a young elephant. It's broken along the growth plate here. The growth plate is not fused, so it's still growing.
How do you explain to people, like in a social setting, about the kind of work that you do?
My work's at the intersection of mechanics, of engineering, and biology, life. And what I do is I bring these two disparate themes together in a unique way to understand how life responds to what is the mechanics of this world. So this is the end we want to get. I go and ask the hardest questions and I try to figure them out. And typically to be able to figure them out, we have to develop a new technology to be able to answer what hasn't been answered before.
So all this incredible equipment and resources, and one thing that we saw being done was feeding the cells. So they still need feeding.
That's right, they're like kids. I always refer to stem cells as being like children. Well, we found out, just like with kids, environment plays a much bigger role than just the pre-programming.
So you talk about regenerative medicine and adaptation. I mean, tell me more about that with tissues.
Life is dynamic. Nothing ever stays the same. Just like my life is changing all the time, if I don't adapt, I'm going to be a failure. Well, these cells, in order to stay alive, they have to adapt. Adaptation is life. So that's one of the sort of taglines of our lab is, I am, therefore I adapt. It's the same thing for these cells. But what we've realized recently is these cells are adapting. And there's a certain plasticity that you can drive or guide that fate process. And that I find very intriguing, and it has huge implications, not only for medical therapies and regenerative medicine, but also for all sorts of new technologies, such as the development of novel materials. Here they're very highly populated, high density. And the femur is designed so that this is essentially a bridge-like structure. There are bending forces that are transmitted via the hip. This is the femoral head. Imagine having a real bridge that adapted in time to commuter patterns, so that adapted in time or healed itself in time as it started to show fatigue or aging.
I need to sterilize the scaffold.
The cells are the expert tissue builders. It turns out one of the hardest problems for a surgeon to take care of, one of the hardest challenges, is to replace tissue where there is none. So it's really difficult to heal something like this, and this is where regenerative medicine comes in.
My name's Hannah Chang, and I did my undergraduate work at Johns Hopkins University. I got a bachelor's in biomedical engineering, and right now I'm a fourth-year PhD student in Melissa Knott-Tate's lab. So right now we're working on some preliminary experiments we've done in sheep, not in human, but we were able to use cells from periosteum tissue in a segment of bone where there is no bone at all. And right now, the kind of what doctors will do is they'll let the bone heal together and then slowly kind of re-break the bone, let it heal and re-break the bone, because the gap is too big for the bone to heal on its own. What we're doing is we're trying to find out a way to use these cells in a kind of a therapeutic tissue engineering scaffold, and they're actually able to heal that gap with just one surgery. And yeah, within 2 weeks, this whole gap is filled with bone. And so we're trying to understand how nature does that, how this process occurs.
Talk to me about your students. You bring a lot of students from across the globe, and why do they want to come here?
We need people in our teams that have as diverse backgrounds, diverse educations, and diverse life histories as possible, so that when we're approaching science and technology's hardest problems, we can really come at the problem with a variety of perspectives. And so I try to reach out and get that kind of diversity on my team at all times. Now, it's not that I'm going out and looking for something specific. People come to me and they're looking to be part of the team.
So my name's Sarah Evans. I'm a fifth-year master's student right here at Case Western. I did my undergrad here also. I'm originally from the west side of Cleveland, North Olmsted, Ohio.
This is some very heady stuff, right? It's a lot of research. It's a lot of intense, scrutiny of stuff. What makes that interesting to you?
It's really interesting because it bridges so many fields to me. You're involved in the medical field, but you also have the sciences. So not only just engineering, but biology, chemistry. Some of my recent work has been biochemistry heavy. So bridging all that together, you really have to continue to learn and continue to grow And just, you can never stop learning, essentially, if you want all these things to merge together to make a successful project.
What's the message here for this lab?
The biggest message is find your passion and do it. Just do it. Don't ever see a barrier as insurmountable. There are no barriers in this world. You just have to find your way to make it work. And I try to empower my students in that way. You know, a lot of students will come in and they'll say, I have a 4.0 average, I'm doing great, but I'm now not doing well in this particular class. I want to drop it because I'm getting a C. And I say, are you crazy? You should not be getting a 4.0. If you're getting a 4.0, you're not taking the right classes and you're not going out of your comfort zone. This is ridiculous. You're not there to prove that you're perfect. You're there to prove that you're imperfect and you have a lot to learn. And I think pushing ourselves outside of our comfort zone, that's how innovation happens. Not by training till I can show I can memorize that book from A to Z. I think everyone has something unique to contribute, and everyone's unique life story gives them a special advantage to do that as well.